Thanks for everyone and good afternoon. I'd like to acknowledge Hort Innovations as the funder of this project. It's project RB22001. You can go to the Hort Innovations website and get some more background information. I'd also like to acknowledge the project reference group that have supported this project and contributed to the successes thus far. The things I'd like to cover in this session is a little bit of background about the project, a bit about environmental metrics and how we might use them. Perhaps one of the questions the industry might have, this is relatively new territory, and why would the industry and Hort Innovations be investing in this sort of work? We're about halfway through the project and we have some early results, so it's a chance to give you some early insights into the sort of information that we're generating, particularly for the metric of carbon footprint, which is an indicator of greenhouse gas emissions contributing to climate change, a very popular metric, but not the only one. And if you're less familiar with this area, we can have a look at what we mean by the greenhouse gas emissions relevant to Rubus berry production and where they're coming from. The value of the sort of information we're starting to generate is that it can inform opportunity. It tells us where the hotspots are. It highlights potential risks we might not have even thought we had, and opportunities for improvement, opportunities for differentiating yourself in the sector, etc. And of course, we're midway through the project. The project goes through for about another 6 months, and we're still interested in connecting with growers particularly, so that we've got a really good data sample. So if you're interested in this project, there's opportunity for you to reach out. So that's the name of the project, Strengthening the Sustainability of Berry Production. The main things we want to get out of this project is some data, some numbers. Often sustainability is talked about in qualitative, descriptive ways, but increasingly there's a need for more sophistication in having some science-based evidence to support claims, etc. And so this project represents a start for Rubus berry production in that space. Like other horticulture industries, these sectors haven't needed to be working in this space because they are generally sort of low emissions intensive industries in relation to greenhouse gases anyway, so they haven't been a sort of a target for action. But increasingly there's a general business case for having information to provide to customers, consumers, etc. So this is a bit of a start of a journey that Australian agriculture and other sectors have been on for probably about 20 years. The other outcome is for the industry generally to understand the scale and significance of potential environmental impacts. This project's looking at a couple of impacts, but there are other environmental aspects that you'd be quite familiar with that this project doesn't quantify at this stage. And the other outcome is important is it provides some data to inform a sustainability strategy moving forward, which might be something that the industry looks at down the track. Where are we at in the project? We've got 3 main stages. We're sort of midway. We're in stage 2 at the moment. Stage 1, which is what I'll be reporting the early results from, was an exploratory phase where we did some case study, farm-specific life cycle assessment studies to generate data specific for those farms. And so it was a learning process for the project team as well, considering that there actually hasn't been a lot of life cycle assessment or greenhouse gas accounting happen for rubus production in the literature. A little bit from Europe, a few studies we could find, but we sort of had to make sure that we were applying the method in an appropriate way for rubus, etc. So thanks to our project reference group members, we were able to recruit some growers who allowed us to generate some trial results. That has helped inform this next stage that we're moving into, which is to increase the data sample so that we can have a representative sample of data that gives us industry benchmarks, for instance, that the industry can use to see how they might be tracking in this space. And then the last stage, which I think is probably the most important stage, where we start to interpret what does this mean, what can we take forward, and hopefully by the end of the project you'll start to see report coming out from the project and hopefully some extension activities to understand where we ended up with. So environmental metrics, and why would you want to use them? Just jump ahead. Cut down the bottom there is a couple of metrics you might be already familiar with. There's metrics that are becoming a bit more familiar in the business world generally. Carbon footprint, which is a greenhouse gas emissions intensity of a product, with greenhouse gases contributing to climate change. The methods and acceptance of these methods has been well established, and so it's a fairly straightforward process of producing one of those, and parts of the industry are already internally collecting data and doing this for their own purposes. The second one, water scarcity footprint. Water footprinting is a concept that's been around. However, the method has evolved quite considerably over the last 20 years. It's been a bit of a moving target. We're using the latest international consensus method, which is not about the consumptive water use across the life cycle of product, but it's more the impacts of the water use. So it touches on water scarcity. So it's a little bit of a different metric that you might not have come across. We're going to talk just about the carbon footprint results in this project, because they're the ones that we're feeling more complete. The water scarcity ones will follow in other stages of the project. Reporting carbon footprints or greenhouse gas accounts is becoming a lot more part of doing business in many sectors, particularly the emissions intensive industries, but also even for sectors such as horticulture's industry might start to be seeing requests from customers downstream in their supply chain for your emission factor or your carbon intensity of your product, so that they can include that number in their own carbon account. So supermarkets, for instance, are gearing up in this space and working out how they might set emission reduction targets. So they're doing baselines of what the emissions of their operations are, and fresh produce is an input to, say, a supermarket operation. So they will be seeking what the emissions, say, of berries sold in their supermarkets might be. So that's the first place we've seen movement. Many companies are also just doing it internally, just to have an understanding of where they're at, see what opportunities might arise from it. And I guess that's where this industry is at this stage. It's for internal purposes. Just in relation, if some of you are interested, external reporting is the last on that list. And that is a summary of some of the emerging reporting. Many of this, I believe, the Rubus and berry sector are probably not exposed to yet, but it is for larger corporations. There's a lot of activity in this space, particularly if you're export exposed. So before I get into giving you some of the early results, I just want to clarify a little bit about the method we use, which is life cycle assessment, suggesting that we're interested in quantifying environmental exchanges with the environment along the whole life cycle of a product from cradle to grave. Those exchanges with the environment are the resources that are consumed and the emissions, pollutants, etc., that are put into the environment. So it's quite like an accounting exercise, but you're accounting flows of things rather than money. And the first thing we do is set a system boundary, which describes what you've covered in that study. And we often aim to go cradle to grave right through to the end of the life cycle. But in this project, we're starting off in a cradle to farm gate system boundary. So that dotted line captures what we're including at this stage. So up to the berries in a punnet at the farm gate. And just to clarify, this project is focusing on rubus production, raspberries and blackberries, not blueberries. As well as the activities that occur on the farm, we also capture the impacts associated with the upstream production of inputs to the farm, electricity, fuels, fertilizers, etc. Okay, so this is a conventional way of representing the carbon footprint results. We add up the greenhouse gas emissions for each of the supply chain stages that we've included in our system boundary, and we lump them all together. We aggregate them together. But of course, we are interested in the end number to some extent, but we're possibly more interested, particularly at this stage, in understanding, well, what's contributing to that number? Where are the hot spots along the supply chain? And so this is a way of representing it as a contributional analysis with the different colours in those bars representing a different aspect of the supply chain. There's a number for raspberries and blackberries. Part of the case study phase was to actually work out whether we could lump, say, raspberries and blackberries together. Were they similar enough that we could cluster them together? But we did find they were different enough to have their own number. And also, we're still interested in where they're, say, even within raspberry production, where there are different typologies or different regional production systems that need to be differentiated. And that might happen. It's likely we'll have regional averages for raspberries and regional averages for blackberries. Blackberries is tending, while we're not finished, we haven't got a huge sample, it's tending to be lower, mainly because the mass yield of blackberries is a bit higher per hectare, and so the carbon footprint per kilo of product is tending to be lower. So that's we always express the results as per kilo of product in this case. So let's just quickly walk through some of let's focus on the number, the end number at this stage, and the table on the side summarizes the indicative carbon footprints from our sample of 4 case study growers, packaged and unpackaged. The reason I've put it unpackaged as well is because some of the other numbers that are published in the literature, which we can compare these against as a sense check, are per unpackaged berries. So we've got a couple of numbers there. So packaged around about 2-ish kilograms of CO2 equivalent per kilogram of berries. And the next one then helps us break down a little bit the contributors to that. And I've specifically clustered them to separate those aspects that are typical of all agricultural activities, which we see repeatedly in the carbon footprint of any sort of agricultural activity, and those aspects that are more specific to protected cropping systems, which is the case for rubus. And that's the activities in a green box are typical of agriculture, and those in the brownish box are sort of the protected cropping. So we always see contribution from electricity use on farm, fuel use in tractors or vehicles, etc., electricity for pumping of water, upstream production of fertilizers, pesticides, etc. N2O is nitrous oxide emissions. They're related to nitrogen fertilizer use. It's one of the main sources of greenhouse gases in cropping agriculture, because the nitrogen that's applied, any significant surplus can be converted in the soils to nitrous oxide, which is a strong greenhouse gas. Now, we've had to make some assumptions here about the rate of release for horticulture. There are some government numbers, some default numbers, which we've applied, but we suspect that it's significantly overestimates it for protected cropping systems in substrate. the numbers we have available to us are more relevant to soil-based systems. So that's probably an overestimate, worst case scenario, and we're still digging into expertise of people who can perhaps have any evidence for what it might be for substrate systems. Then the establishment phase is that aspect where you've got to grow the plant for a period of time, a nursery, and up until the first flush of fruit. And then a little bit for transporting of plants that are moved around the country, a bit long canes, etc. So those green box ones is very typical. The bottom ones is associated with packaging materials. Rubus berries, because highly perishable, are quite packaging intensive per unit of product. That counts for the plastic punnets and the cardboard trays. And the infrastructure, so the tunnels, the plastics, the metal, etc. And we found that infrastructure related aspects are quite significant. One little point to make is we often lump it together per unit of product, but people acknowledge, of course, that just because you're a grower of berries, that you are responsible for all of those aspects throughout the whole supply chain. So in greenhouse gas accounting, we can also subdivide that into who owns the emissions, so to speak, scope 1, scope 2, and scope 3 for those of you who are interested. So for a grower, scope 1 is the top box. So they're the ones that are related to what you do on farms, and then the others are really related to the things you buy in, etc. Now, just to put this in perspective, this was a useful paper published by some Australian researchers some time ago, where they, based on a desktop review of carbon footprints of a range of food products, they showed the range for comparison from vegetables and fruit down the left-hand side through to cereals, rices, etc., up, and then to the right into the protein. So we know very well that protein foods come with a much higher emissions intensity. But what it showed us is that fruits have much lower emissions intensity, and the numbers that we have got, if you hone in on the horticulture, the numbers we've got so far are in the ballpark of what we're seeing in literature. And a slight difference between fruits field grown and fruits in a controlled sort of greenhouse environment. Just getting towards the end, as well as generating numbers, we also spend time in talking with the growers about what does this mean? Does this flag any areas for improvement? And we're just starting to collect lists of potential opportunities that might be considered in subsequent phases when the industry is considering a sustainability strategy. One of the important things is if farmers and growers, businesses want to do something about this, it's important to know where you should focus your efforts. We find in this game there's a big difference between perceptions of environmental impacts and actual environmental impacts. And so often it's very easy to run away and spend effort on things which are actually less significant. We heard early on that importing substrate or all that travel overseas might be a big environmental issue, but it's actually minuscule. Sort of don't even bother about it. Whereas other things are more important. So that's the phase we want to leave the industry with. We're still working on this project. These were early insights. Maybe at next year's conference, we might have an opportunity to give you the results from the bigger sample with some industry benchmarks, etc. We're still very keen to talk to growers who can help add to our data sample. So if you're one of those, or if you know someone, then please get in contact. Thank you for that. I have to run away after this session, but if anyone is interested, I have left my card there with some details of how to get in contact some more. And as well as myself, you can also contact Hort Innovations. Onyeka Netsi is our project manager. Great, thank you.
I reckon we can do one question if anyone has a question.
Hi there. Infrastructure was a big piece of it, assuming that's steel with hoops. That has a long life cycle. How did the life cycle of the crop, which is 8-9 months, factor into the life span of the infrastructure?
Yes, what we do for all infrastructure is we amortize it per unit of production. So yeah, we do account for its lifetime and how much production goes through its lifetime, and it's amortized the same way you do economically.
Thank you. Thank you, Marguerite.